Hey guys, welcome to the sixth episode of the AI series. In today's video, we're going to take a look at what exactly is training data and testing data. So let's get straight into it. A few videos ago, we said the real goal of a machine learning model is generalization, which is being right about data you've never seen and not just memorizing things in the training set. And to measure that, we hide some data away and test the model with that data. It's a quite simple idea, but doing it honestly without accidentally lying to yourself is harder than it looks. And getting it wrong is one of the most common ways promising models fail the moment they meet the real world. So this video is the protocol on how you split your data so the score you get is a score you can actually trust. Let's start with a basic split. The big slice, usually around 80%, is the training set. The model is allowed to study these freely. The remaining 20% we seal away as the test set, and the model never sees it during training. Think of training data as the practice problems and the test set as the final exam. And the whole point of an exam is that you didn't get to see the questions in advance. You train on the blue, which is the training set, then exactly once you check against the red, which is our test set. That goal score is your honest estimate of how the model handles the unseen. Now, the part most beginners are never told about is that there's usually a third set. Here's the problem it solves. Some settings in a model aren't learned from the data at all. You choose them before training even starts. How complex to let the model get, how big a step it takes while learning, which algorithm to use. These are called as hyperparameters, and you got to tune them by trying options and seeing which scores best. But here's the trap. If you tune them by reviewing the test set, you'll effectively let the model study the final exam paper, and your test score eventually becomes a lie. So we carve out a third slice, the validation set, purely for this tuning. You train on the training set, tune your choices against the validation set, and keep the test set sealed and untouched until the very end. Train, validate, test. Three jobs using three separate piles of data. Now, even with three clean splits of our data, there's an even subtler way to fool yourself, and it's responsible for an enormous number of models that look brilliant in the lab on the training set but collapse in production. That is called as data leakage, when information from the test set sneaks in to the training set. The classic example is when you decide to rescale your features, like we discussed last video, but you compute the scaling using the whole dataset. So you change the settings according to the whole dataset, which also includes the test set. And your score is inflated. And but you compute the scaling using the whole dataset, which also includes the test set. At now, it seems quite harmless. But now the training process has quietly absorbed a bit of the test data and your score is inflated. Other leaks in data are just as sneaky. The same record event the same record accidentally sitting in both sets or using a piece of information that wouldn't actually be available at prediction time. So here's the thing to sit with. Your model just scored 99%. Why might that be a reason to worry and not celebrate? Now, let's say you barely have enough data to begin with. Carving off 20% for validation can feel like a painful waste. The elegant fix is cross validation. Instead of one fixed validation set, you slice the training data into, say, 5 equal folds. You train on 4 of them and validate on the 5th. Then rotate so each fold gets a turn as a validation set. 5 times over, you average the 5 scores and get a more stable estimate. While every single data point has pulled double duty as both training and validation. It costs more computation. You're training 5 times instead of once, but when data is precious, it's almost always worth it. Now, let's take all this back. And one rule sits above everything: the test set is only touched once, at the very end, and never again. The instant it influences a single decision during development, it stops being a fair exam for the model and becomes part of the answer key, which is our training set. We have to guard it, and it will do something genuinely rare. It'll tell you the truth about your model before the real world does. And speaking of the truth, the failure this whole protocol is built to catch is a model that aces its training and flops on the unseen, which has a name and it's important enough to get its own video. And that is known as overfitting, and it's going to come up in the next few videos to come. If this video helped you understand what exactly is training data and testing data, then make sure to subscribe and hit the like button for more videos like this.